Question 1. Simplify the expression 4 plus 6i over 3 minus 2i. So for this problem, just rewriting it real quick. For this problem, we aim to get the imaginary number out of the denominator, and this will hopefully help us simplify. So when we are doing something like this, we can use a tool known as a complex conjugate, which is if we have a fraction in the form, let's say a plus bi over c plus di, what we can do is we can multiply the top and the bottom of the fraction by the denominator of this fraction with basically the negated sign in the center. So instead of being c plus di, it will be c minus di. And if this were c minus di, then this would be c plus di. Doing this will get rid of the imaginary number in the denominator. So for our problem, we take 3 and we add 2i, and then we multiply the top and the bottom by this expression. So it's going to be some arithmetic, some algebra. So 4 times 3 is 12. We're just foiling, right? 4 times 2i is plus 8i. 6i times 3 is plus 18i. And then 6i times 2i is minus 12, right? Because I times I is negative 1. In the denominator, you're going to see how this complex conjugate rule works out. 3 times 3 is 9. 3 times 2i is plus 6i. Negative 2i times 3 is minus 6i, right? So these two terms are going to cancel. And then negative 2i times 2i is going to be, let's see, I times I is negative, times the negative is a positive, is a plus 4. Okay? So we'll simplify on the top. These two terms are going to cancel. We'll end up with 26i, looks like. And then on the denominator, these two terms will cancel, and we'll be left with 13. Now we have 26 over 13. 13 goes into both of these numbers, so we can simplify. We can just drop out the 13 from both of these. 13 divided by 13 is 1, and 26 divided by 13 is 2, so we're just left with 2i, and this is our final expression. Okay, moving on to question 2. Find 5x cubed minus 3x squared plus 7x plus 2, all divided by x plus 6 by synthetic division. Alright, so synthetic division is kind of a pain, but it can be useful in certain circumstances. For us to use this particular version of synthetic division, it's important that the coefficient on the denominator, right, this value right here, it's important that this is 1. In this case it is, right? This is just simply x. And it's also important that the degree is 1, which obviously it is. So since we have that, we can use the method I'm going to show you. Essentially what we do is we're going to draw a little box, right? And we're going to take the negative of whatever value we are tacking onto the end here. In this case, it's negative 6, and we're going to drop that out in front of the box. Now we're going to take every coefficient, each coefficient on each term, and we're going to put them into the box like this. So we have 5, we have negative 3, we have 7, and we have 2. Now what we're going to do is we're going to do this kind of, it's almost like magic, frankly. It's this method that you don't really probably learn how it actually works, but it can still be useful, especially if you have to learn it for a test or whatnot. I might upload an explanation of how it works at some point soon, but I'll just run through it quickly. So for the first term, we're essentially going to add downwards. So since there's nothing here, right, it's basically a 0 underneath here, we're just going to drop our 5 down. So we're just going to drop down 5. Now we're going to multiply negative 6 times 5 and put it up below the negative 3, the next term in the list. Negative 6 times 5 is 30. Sorry, negative 30. It's important. We're going to add these two terms. Negative 3 plus negative 30 is negative 33. right? We're going to multiply -6 times -33 and bring it up here below the 7. In this case, it is 198. Now we're going to add 7 plus 198 and bring it down. And this will be 205. And now we're again going to multiply -6 times 295, and this will give us -1230. Just adding 2 plus -1230, or 2 minus 1230, this will give us -1228. And now we're just going to put a little break here, because this is going to be a special term in our list. But essentially, these are the coefficients on the polynomial that is remaining after this division process. So this is going to be the x squared term, this is going to be the x term, and this is going to be the extra constant term. After division, we're going to be left with, I guess I should write this out to make it more clear. So I'm just going to rewrite all of our division. This is divided by x plus 6. This equals, the 5 here is going to be tacked on to x squared. -33 is going to be our x term. 205 is going to be our constant term. And now all that remains is, well, this remainder, essentially. So this is going to be -1228. And this is going to be divided by the denominator of this fraction up here, the one we started with. So x plus 6. This won't always happen, but it does happen frequently. So it's important to sort of remember that you have to add this term onto the end. But this is how you would get this expression. This is how you would solve this, this division by synthetic division. All right, our last question. Question 3. Use the fundamental theorem of algebra to determine how many roots the function f of x equals 4x to the 5th divided by 3 minus 7x to the 4th plus 3x squared minus 17 has. So the fundamental theorem of algebra states essentially that for any polynomial of degree n, we are going to have exactly n number of roots. Now this can be repeated roots, so sometimes you'll have, if you have an expression, a quadratic for instance, you might have x equals 0 twice, and this is a double root. Essentially, whatever the degree of the polynomial is, the highest degree, is the number of roots the function has. So for this problem, literally all you need to do is just look at that first term and look at the degree it is of, and that's the number of roots you have. So in this case, the function has exactly 5 roots. Some of them might be complex, some of them might be doubled, but this is the number of roots it has.